Hello friends, welcome. So today I am back with another problem solving question. It is a very tricky question. So let's see how the question goes. Question says that which of the following sets includes all of the solutions of x that will satisfy the equation absolute value of x minus 2 minus absolute value of x minus 3 is equal to absolute value of x minus 5. Now before we proceed, if you look at this, all of the solution of x, so the set that includes all of the values, all of the solutions of x, okay. Now in that particular set, not all the values are the solution of x, okay. Please bear that in mind, that in any set not all the values are the solutions of x, but your answer does contain all the solutions of x, okay. Please do remember this point. Now why is it important? Because by looking at this question you might be thinking that why not pick up a value and put it in the equation and see if it satisfies, okay. It won't work that way, because all the sets including your answer do have values that are not the solutions of x, okay. So that way you will be wasting a lot of your time, because there are so many different values to check, so that will take a lot of time, so that way it will not work. So in a way this question is forcing you to actually solve the equation and look for the solutions of x, okay. So don't get worried, this question is not very difficult, just be with me on this, okay. So the equation that you are given is this: absolute value of x minus 2 minus absolute value of x minus 3 is equal to absolute value of x minus 5. All right, now let me rewrite this equation and make it simpler, okay. How? So this becomes absolute value of x minus 2 is equal to absolute value of x minus 5 plus absolute value of x minus 3. Now this way it is more simpler. How? So if you try to represent this equation in a number line, so it will look like this. See what exactly this equation means. It means that the distance between some unknown number x and 2, okay. So this distance between x and 2 is actually equal to the distance between that number and 5 plus the distance between that number and 3. Okay, so let us try and locate these points on the number line. So let's say you have 2, 3 here and 5 here. Now that number is unknown, but what we are given is that distance between that number and 2 is the sum of the distance between that number and 5 and the distance between that number and 3. All right, now use your common sense. What if this point is less than 2? It is towards the left of 2. Let's say x is here. Will this work? So distance between x and 2, and this is absolute value, so we don't care what is the sign, we just looking for the distance, okay, the positive number. Okay, so what is the distance between that point and 3 plus distance between that point and 5? Is the sum of these two is going to be distance between x and 2 in case x is to the left of 2? Right? Our common sense says it's not possible, okay, because this distance is never going to be the sum of these two. All right, so clearly your x does not lie towards the left of 2. All right, so now let's check if x is between 2 and 3. All right, so let's say if your x is between 2 and 3, so will it work now? So this distance is equal to sum of this and this distance. Again, our common sense says that this is not possible, because this distance is going to be really very small compared to this plus this, right? So again, x is not between 2 and 3. Okay, so what? Let's check here. Let's check between 3 and 5. Is it possible between 3 and 5? Let's say your x is between 3 and 5. So this distance is equal to sum of this distance and this distance. Now this looks quite possible. Now can you think of a value? How about x is equal to 4? Yeah. So if x is equal to 4, what happens? This distance, absolute value of 4 minus 2 is going to be 2. And this is equal to absolute value of x of 4 minus 5 is going to be 1, plus absolute value of 4 minus 3 is also going to be 1. So you see you're getting 2. LHS is equal to RHS, right? So definitely one of the solution is going to be x is equal to 4, because for x is equal to 4 this equation is satisfying itself. So now let's get rid of the options where x is equal to 4 is not there. Okay, so if you look at the first option, it does not contain x is equal to 4, so definitely we can get rid of that. This option has x is equal to 4, so let's keep it. Similarly, this also has, third one, this also has, so let's keep it. Now if you look at this one, it does not have x is equal to 4, but this one has. So we can get rid of 2 of the options. Let's see and if we can get rid of the rest of the option. Okay, so now let me make another number line here and see if we can find another solution. So right now we checked between 3 and 5. Now what is left to check? We have to check what if x is to the right of 5. That's the only portion where we need to check, right? So let me change the color here and let me draw the points. So 2, 3 and 5 here. Now we have to check x is here. So let's say x is here somewhere. Now distance between x and 2 is equal to sum of the distance between x and 5 and then x and 3. This looks quite possible, right? What if x is 6? Okay, so if x is 6, so x minus 2, so 6 minus 2 is going to be 4, is equal to, let's check this side, so right hand side. So it will be 6 minus 5, the absolute value is 1, plus 6 minus 3, the absolute value is 3, which is again 4. So LHS is equal to RHS. So even for x is equal to 6, you can at x is equal to 6, this equation holds true, right? So we can say that x is equal to 6 is also a solution of this equation, right? So now let's get rid of the options where x is equal to 6 is not there. So if you look at this option, it does not contain x is equal to 6. Similarly, if you look at the last one, it does not have x is equal to 6. So the only option that we are left with this, right? So you see both 4 and 6 are part of this set. As I told you, the remaining 5 minus 4, 0, 1, they may not be the solution of this, but this set definitely contains all the solution of the equation. All right, so see, absolute value equations are not that difficult. All you have to do is to use some common sense, and usually the weightage is quite high in GMAT for such questions. So take advantage of that, use your common sense, and I'm sure you'll be good to go. I hope that helped. Thank you.